So far, we have discussed Fourier series of period T is. Today we'll discuss Fourier series of orbital period. A function fx need not always be defined in the interval pi. When the length of the interval is other than 2 pi, so denote that by a 2l. A general interval of length 2l be cc plus 2l. The Fourier series of fx in the interval c to c plus 2l is given by f of x is equal to a naught by summation n is equal to 1 to infinity an cos n pi by l x plus summation n is equal to 1 to infinity bn sin n pi by l x, where a naught is equal to 1 by l integration from c to c plus 2l f of x dx, and an is equal to 1 by l integration from c to c plus 2l f of x cos n pi by l x dx, and bn is equal to 1 by l integration from c to c plus 2l f of x sin n pi by l x dx, where a naught, an, bn are constants, and these are called as Fourier coefficients. Here also we can compute a naught, a and bn by using the concept of even and odd nature. Suppose the interval is minus L to L. Substitute x is equal to minus x in f of x. If you get plus f of x after substituting or replacing x as a minus x, if you get plus f of x, then it is an even function. Then a naught, an we need to calculate, and bn will be 0, and a naught is 2 by l integration from 0 to l f of x dx, and an is 2 by l integration from 0 to l f of x cos n pi by l x dx. Suppose f of minus x is equal to minus f of x, then it is an odd function, and a naught and an both equal to 0, and bn is 2 by l integration from 0 to l f of x sin n pi by l x dx. So it is for minus L to L interval. If suppose interval is 0 to 2L, so replace x as a 2L minus x in f of x. After replacing x as a 2L minus x in f of x, if you get f of 2L minus x is equal to plus f of x, even function, bn is 0, and a naught is 2 by l integration from 0 to l f of x dx, and an is 2 by l integration from 0 to l f of x cos n pi by l x into dx. If it is minus f of x, then a naught and an both equal to 0, and bn you will get 2 by l integration from 0 to l f of x sin n pi by l x dx. Now working procedure, very simple one. So if a period of the function is other than 2 pi, so equate that period with 2l to get the value of this l, and compute a naught, an, bn, and substitute in Fourier series, so you will get the required answer. So with this, so we'll solve examples. First one, obtain the Fourier series of fx is equal to mod x in minus L to L. Hence show that 1 by 1 square plus 1 by 3 square plus 1 by 5 square, this is equal to pi square by 8. Here function is mod x. Mod means here by taking negative values also, we will get here positive values, and interval is minus L to L. Now, so period of this fx will be b minus a. So this is a and this is b. So L minus of minus L is 2L, right? No need to find the value of L, because this interval is in terms of what here, L. So that is minus L to L. Fourier series of period 2L is given by f of x is equal to a naught by 2 plus summation of n is equal to 1 to infinity an cos n pi by l x plus summation n is equal to 1 to infinity bn sin n pi by L x. Now we shall check for even and odd nature of this function. Interval is minus L to L. So substitute x is equal to minus x in f of x. So that is f of minus x is equal to mod of this minus x. So mod means here we have to consider positive values only, that is mod x. So mod x means it is a f of x. F of minus x is equal to f of x means the given function f of x is even function, and consequently bn is 0. We need to calculate here a0 and an, where a0 is equal to 2 by L integration from 0 to L f of x dx, and an is equal to 2 by L integration from 0 to L f of x cos n pi by L x dx, and a0 is equal to 2 by L 0 to L f of x is x, because we are considering only positive values, and f of x is mod x. Positive values means here plus x, that is x. So 2 by L integration from 0 to L x dx. So integrate this with respect to x, 2 by L as it is. Integration of x is x square by 2, where is from 0 to L. Limits from 0 to L, always upper minus lower. Take this 2 outside, so 2 get cancels, so 1 by L, and x square limits 0 to L. Now substitute upper and lower limit. A0 is equal to 1 by L. Upper limit is L, x square is there, L square, minus lower limit is 0. So 1 by L, L square, yeah, 1 L get cancels with this. So A0 is equal to L, and A0 by 2 is L by 2. Now find An. An is equal to 2 by L integration from 0 to L. F of x is x cos n pi by L x dx. Now so observe this one. So this is x and this is cos, means it is a product of two functions. One is polynomial and other is trigonometric. So always we apply here uh, generalized Bernoulli's rule, integration by parts. So here u is x and v is cos n pi by L x. So 2 by L x means it is a u. Next we want v1. v1 is integration of v. So integration of cos n pi by L x is sin n pi by L x divided by n pi by L, and derivative of this x is 1, and integration of v1 is v2. So integration of v1 is integration of sin n pi by L x divided by n pi by L. So here 1 upon n pi by L, you take it outside. Integration of sin n pi by L x is minus cos n pi by L x divided by n pi by L, and here 1 upon n pi by L we have taken outside, and n pi by L raised to 2, because multiply this 1 upon n pi by L. So you'll get this as integration of sin n pi by L x divided by n pi by L as minus cos n pi by L x divided by n pi by L raised to 2, limits from 0 to 1, because integration differentiation or derivative of this one, derivative of 1 is like a constant, so derivative of this constant is 0. 0 into something is 0, so next terms you will get this as a 0. 2 by L as it is, taking this 1 upon n pi by L, so taking reciprocal L divided by n pi, x sin n pi by L x limits 0 to L, and this minus is plus, and 1 upon n pi by L raised to 2, taking reciprocal, and you'll get this as L square divided by n square pi square cos n pi by L x limits 0 to L. So substitute upper and lower limit. Now I'll take the advantage of this sine function and limits L and 0. Upper limit is L and lower limit is 0. In place of x you substitute L. So L get cancelled, sin n pi. Sin n pi is 0. and in place of x substitute 0, so that is sine 0. Sine 0 is 0, or else multiply this x sine n pi by l x and multiplied by this x is there. So in place of x you substitute 0, 0 into something is 0. So you'll get this whole term as a 0. Now an is equal to L square, 2 by L is there, L square divided by n square pi square, and apply limits for what here? Cos n pi by L x limits 0 to L. Now substitute upper and lower limit, 1 L get cancels with this, an is equal to 2L divided by n square pi square cos n pi minus cos 0. Substituting upper limit as L, L get cancels cos n pi, and lower limit as 0, cos 0 into something is 0, so cos 0. Now 2L divided by n square pi square, cos n pi is minus 1 raised to n and cos 0 is 1. So minus 1 raised to n minus 1. Now take minus as a common and take it outside. Minus 2 by L minus 2L divided by n square pi square, 1 minus minus 1 raised to n. Now an is equal to minus 2L divided by n square pi square, 1 minus minus 1 raised to n. Now substitute this in Fourier series. So f of x is equal to a naught by 2 L by 2 plus summation of n is equal to 1 to infinity. An is minus 2L divided by n square pi square, 1 minus minus 1 raised to n. So this is an cos n pi by L x, and Bn is 0. This is a required Fourier series. And now we want a series. So for that series, so x is lies between minus L to L. Now I want this term as a 1. How to make this term as 1? Possibility will be what here? By substituting x equal to 0. By substituting here x is equal to 0, that 0 is also between minus L to L. If you substitute x as a 0, so cos 0 is what here? 1. Right. Now substitute x is equal to 0 in equation 2. So f of 0 is equal to L by 2 minus 2L divided by pi square, summation of n is equal to 1 to infinity 1 by n square, 1 minus minus 1 raised to n cos 0. Now what is f of 0? So f of x is x. So f of 0 is 0 because in place of x substitute 0. So 0 is equal to L by 2 minus 2 by L pi square, summation n is equal to 1 to infinity 1 by n square, 1 minus minus 1 raised to n, because cos 0 is 1. Now take this L by 2 from RHS to LHS, minus L by 2 is equal to minus 2L divided by pi square, summation of n is equal to 1 to infinity 1 upon n square, 1 minus minus 1 raised to n. Now take this minus minus get cancels and L also get cancels. Take this 2 by pi square from RHS to LHS. So we'll get here as pi square by 4 is equal to summation n is equal to 1 to infinity 1 upon n square, 1 minus minus 1 raised to n. But 1 minus minus 1 raised to n is 2 when n is odd, and 1 minus minus 1 raised to n is 0 when n is even. So pi square by 4 is equal to summation of n is equal to odd values of n. So 1, 3, 5, 7, 9, so on up to infinity 1 by n square. This is as it is. For odd values of n, we have 1 minus minus 1 raised to n is 2. So substitute. Take this 2 to this side. So pi square by 8 is equal to pi square by 8 is equal to substitute n is equal to odd values 1, 3, 5, 7, 9, so on. So we'll get here as 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus so on. So we get here 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus so on. This is equal to pi square by 8, or pi square by 8 is equal to 1 by 1 square plus 1 by 3 square plus so on. So this is a required series. Now move on to the next example. Express fx as a Fourier series, f of x is equal to pi x, x lies between 0 to 1, and f of x is equal to pi 2 minus x for x lies between 1 to 2, and hence deduce that pi by 2 minus 4 by pi cos pi x divided by 1 square plus cos 3 pi x divided by 3 square plus so on. This is first one, and second one is pi square by 8 is equal to summation of n is equal to 1 to infinity 1 upon 2n minus 1 raised to 2. So this is a discontinuous function. 1 is the point of discontinuity. So fx is defined like this. X lies between 0 to 1. So we have function as f of x. I'll take this function as a pi of x. So pi of x is equal to pi x. Now x lies between 1 to 2. So we have function as a pi 2 minus x. So I'll take this pi 2 minus x as a psi of x. Now what will be the period? So period of this fx will be starting point is 0, ending point is 2. So this is a and this is b. Period is b minus a, that is 2 minus 0 is 2. Now equate this with what here? 2l, because arbitrary period is 2l. So equate this with 2l. So 2l is equal to 2. So l is equal to 1. Now Fourier series of fx having period 2 is given by f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos n pi x plus summation n is equal to 1 to infinity bn sin n pi x, because l is equal to 1. We shall check for even and odd nature, whether we'll get even function or odd function, or we may get neither even nor odd function also. Here fx is defined in the interval 0 to 2. So compare this with 0 to 2l. So we'll get here 0 to 2l, right? So phi of x is pi x and psi of x is pi 2 minus x. Now 0 to 2l in the form of this what here 0 to 2l means in place of x you have to substitute 2l minus x and l is 1. So in place of x 2 minus x, where in phi of x. So phi of 2 is equal to 2 minus x. So this is nothing but psi of x. So phi of 2 minus x is psi of x, means the given function is even function in the interval 0 to 2. So obviously bn will be 0 and a naught is 2 by l. L is 1. 2 by 1 is 2. 2 in integration of 0 to l. L is 1. 0 to l f of x dx. Similarly an is equal to 2 by l. 2 by 1 is 2. 0 to L. L is 1. So 2 integration of 0 to 1 f of x cos n pi x dx, because L is equal to 1. Now calculate a naught and an. Now a naught is equal to 2 integration from 0 to 1 pi x dx, because in this interval 0 to 1 our function is what here? Pi x. Now integrate this, take this pi outside, 2 pi integration of this x is x square by 2, limits varies from 0 to 1. Now take 2 outside, cancels this with 2, so you'll get 5 x square, limits varies from 0 to 1. Substitute upper and lower limit, this pi as it is, in place of x1, 1 square minus 0. So 1 square minus 0 is 1. So multiply this with pi. So a naught is equal to pi and a naught by 2 is pi by 2. A naught by 2 is pi by 2. Now calculate an. So an is equal to 2 into integration of 0 to 1 pi x cos n pi x dx. So observe this one. So this is a product of two functions. We need to apply generalized rule integration by parts. U is pi x and v is cos n pi x. So an is equal to 2 pi, take it outside, x as it is, integration of cos n pi x, that is v1, integration of cos is sin n pi x divided by n pi. Differentiation of this x or derivative of this x is 1 And integration of sine n pi x divided by n pi is minus cos n pi x divided by n pi raised to 2, varies from 0 to 1, because integration of this 1, sorry, different derivative of this 1 is 0. 0 into something will be 0, so next you will get this as 0. Now an is equal to, now here see, for sine n pi x is there. So in this you substitute 1, you'll get sine n pi is 0, and substitute 0, 0 into something is 0, so you'll get for both the values, for both limits you will get 0. So you need to apply here limits for only this cos n pi x. Now an is equal to 2 pi divided by n square pi square. This minus is plus cos n pi x, limits 0 to 1. In place of x 1, in place of x 0. So an is equal to, and now you take this n pi square, n pi raised to 2 as a n square pi square, take it outside. 2 pi divided by n square pi square cos nx, limits 0 to 1. So 1 pi get cancels with this. An is equal to 2 divided by pi n square. In place of x 1, cos n pi, minus in place of x 0, cos 0. Cos n pi is minus 1 raised to n, minus 1, into 2 divided by pi n square is as it is. I'll take minus as a common. So an is equal to minus 2 divided by pi n square, 1 minus minus 1 raised to n. So this is an. Now substitute this in Fourier series. F of x is equal to a naught by 2 is pi by 2 plus summation n is equal to 1 to infinity minus 2 divided by pi n square, 1 minus minus 1 raised to n cos n pi x. Now Bn is 0. So you'll get f of x as pi by 2 minus 2 by pi, summation n is equal to 1 to infinity 1 by n square, 1 minus minus 1 raised to n cos n pi x. But 1 minus minus 1 minus minus 1 raised to n is 2 when n is odd, and this is 0 when n is even. Now f of x is equal to pi by 2 minus 2 by pi, summation of n is equal to, taking odd values 1 3 5, because even values of n you will get this as a 0. N is equal to 1 3 5 up to infinity 1 by n square into 2 cos n pi x, right? Now to get that first result, f of x is equal to pi by 2, 2 into 2 is 4 minus 4 by pi, go on substituting n as a 1 3 5 7, means odd values. So cos pi x divided by 1 square plus cos 3 pi x divided by 3 square plus so on. So this is a first result. Now we want second result. So for that I want cos term as a 1. So this is possible only when by substituting this x as 0, because by substituting x, so all the terms you will get here as a cos 0. So cos 0 is 1, right? Now substitute x is equal to 0, and this 0 is, and this 0 is what here? This 0 is this, uh, 0 is lies between what here? Interval 0 to 2. Now substitute here x is equal to 0. So we will get here as a f of x 0 is equal to pi by 2 minus 4 by pi, 1 divided by 1 square plus 1 divided by 3 square. You can guess next, 1 divided by 5 square plus 1 divided by 7 square plus so on. Now f of x is pi x, because in 0 to, because we have considered even and odd function, right? So interval will be what here? We have considered interval as a 0 to 1. So in that interval we have fx as a pi x. In place of x substitute 0, you will get f of 0 as 0. So 0 is equal to pi by 2 minus 4 by pi, 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus so on. Take this pi by 2 from RHS to LHS, plus becomes minus. Minus pi by 2 is equal to minus 4 by pi, 1 by 1 square plus 1 by 3 square plus so on. So minus minus get cancels. So take this 4 by pi from RHS to LHS. So pi square by 8 is equal to 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus 1 by 7 square plus so on, right? So today I'll stop here only, and in tomorrow's class, so we'll discuss few more examples on this arbitrary Fourier series, right? Now